Okay, we're going to do chapter 3 and 4 for electronic commerce. Chapter 3, we're going to talk about the infrastructure of the internet, the web, and mobile platforms. And then when we get to chapter 4, chapter 4 was about e-commerce presence, so websites, mobile apps, and mobile sites and apps. Okay. So chapter 3 is quite extensive. It's about 75 or so pages, so we'll try to get through it as quick as possible. But it is some of the more technical material in this course, so I may stop and dive a little deeper into some areas. Okay, so let's first talk about the internet. What is it? Okay, the internet is a network of computers and other networks. They're interconnected, and they allow us to do business connectivity, academic connectivity, government connectivity, and individual connectivity. And every single one of us has a local area network that we use within our homes or our dorms or our businesses or whatever. And then those are connected together through what's called a wide area network, or WAN. Now, the internet is much broader than the World Wide Web. So the World Wide Web is part of the internet, but it is not the same as the internet. Okay, so the internet is the network, and it has many different applications that run on top of it. The World Wide Web, or the web, is one of those applications, okay, or services. And so today the web is the most popular of what we have use of on the internet, aside from email, of course. But there are a lot of other components of the internet that maybe aren't used as much these days. News groups, file transfer protocol servers. Before the web, there was this thing called Gopher, Telnet. These types of things are all services that are on the internet. Okay. Now, the evolution of the internet. So the early days was a period of innovation, of connecting computer systems together. So that would be in the 1960s and 1970s. And the internet itself came about from a project started by the Defense Advanced Research Project Agency, or DARPA. Okay? In fact, it used to be called the DARPANet. And then over time, it eventually was taken over by the National Science Foundation in the 80s. So we started seeing it used in academic institutions and maybe some businesses in the 80s and 90s. And then starting around the mid 1990s, you really saw it take off in the commercialization phase. And prior to the mid 90s, the World Wide Web was invented around 1989, I believe. And the web browser and the World Wide Web itself. But it took about 5-6 years for it to really take off in terms of commercialization. And then after commercialization, that's where we are today, and it's been ongoing, and we've had multiple versions of commercialization. So the Web 1.0 from the 1990s through sometime in the mid-2000s. Then we had Web 2.0 around the time that Facebook and other social media took off. And then as we shift forward into today, we're starting to see Web 3.0 with personalization, Internet of Things, artificial intelligence, etc. All right. So a lot of different things go into it, and there's a timeline in your book, and I'm not going to go through the entire timeline, but I'll talk about a couple of key points here. Okay. Ethernet, invented in the 1970s. This was a way to link computers together. So in the 80s and 90s, businesses would have a LAN, and they would connect their computers together and share information. TCP/IP, which is the protocol. Think of it like the language of the internet. Okay, this is how computers can talk to one another. They all speak the same language. We call that a protocol. So overall, for a communications protocol, we use what's called TCP/IP. It stands for Transmission Control Protocol, Internet Protocol. Okay, so if you've heard of TCP/IP, that's what that stands for. Now, we had a few inventions that not necessarily of the internet, but helped to drive the development of things that we take for granted today. So some of you may remember something called HyperCard. It was a hypertext system from Apple that ran on the Macs and on the Apple IIgs. Okay. And what this was a tool that allowed you to, kind of like PowerPoint, I guess is the best way to describe it if you're not familiar with it. You can have interactive presentations to share information. And I recall back when I was in high school, was in the Clinton administration. I'm that old. But I remember doing a paper on his equivalent of the Affordable Health Care Act or Affordable Care Act. And I did my paper like any other paper, but I had to do a presentation, and I used HyperCard. And I think I was the first person that ever used HyperCard in my school system because it was received quite well. But it was a way to link information and even link information out on the regular internet. So we had internet, and I was able to link to some Gopher and web resources from that. Let's see, moving on, the domain name system. So this came about in the mid-'80s. And so the DNS system, or domain name system, is the equivalent of the phone book for the internet. Okay. And some of you may not even know what a phone book is, because we haven't used them. Most people haven't used them in quite a while, but that's okay. It's basically a way to translate names and numbers. So the addresses of systems or computers on the internet to a human-friendly name that we can remember. So google.com is just a human-friendly name. And if I were to look up google.com, I'll do that on my computer here. I'll look it up with the DNS. I can see that google.com is, according to my computer at least, 216.58.217.206. Okay. And then if I figure out where that goes, how do I get there? Okay. So kind of the GPS of directions, and it may not let me. Yeah, it does. Okay. So I can see that I go to my local router. Then I can see that I go to another router. Eventually I get to 209.85.143.255, which takes me to another one, 108, 170, 230, 125. And eventually I get to 216.58.217.206. Okay. How does that all happen? Well, first of all, the DNS system has like a big giant database of records of hosts, or the DNS name like google.com, to the IP addresses that belong to an actual computer. Now, I'm simplifying this, and it's much more complex than this, but for the sake of this class, I'm simplifying it fairly significantly, okay? Because I'm not bringing in concepts like high availability and having clusters of thousands of systems. That's what Google has. That's what Facebook has. I'm not getting into that level of complexity for this class. There are classes where you would get into that level of complexity, though. Okay, so just assume that you have some sort of IP address to host name conversion, and we use the DNS system to look that up. Okay. And so our computers have DNS enabled, and usually our DNS comes from our internet provider. But Google offers a DNS that we can point to instead. So Google's DNS is very simple. It's just 8.8.8.8. Okay? And so if you use that, that's Google's DNS, and you can resolve things using Google as opposed to your own internet provider, if you wish. So if your internet provider's DNS isn't working, you can always use Google as a backup. All right. Now, DNS allows us to have a user-friendly name. So think about it in your phone. I don't know the numbers for people in my phone. I just know their names. So I punch their name, and my phone knows who this is. Okay. All right. Now, we move on to the World Wide Web. So in 1989, as I mentioned earlier, the World Wide Web was invented. Okay. And so this was invented by a guy named Tim Berners-Lee. Okay. And he did a paper on something called hypertext markup language and the idea of having hyperlinked documents. So thinking that concept from HyperCard, from Apple HyperCard, and now applying it to having a browser and documents that have a common markup language. Because before this point, every document that you might share with someone was in a proprietary format like Microsoft Word, or maybe it was a text file. PDFs didn't exist back then. PDFs were, those came later, okay? So if I wanted to share a document with someone, I either had to share it as a plain text file and lose all the formatting, but most people could open that, or I had to share it in a specific format, and what if the person didn't have the program to open it? So let's say Microsoft Word. I want to send you a document, I send it in Microsoft Word, but you don't use Microsoft Word, you use something called WordPerfect, which was at one time a competitor to Microsoft Word. So now you can open WordPerfect, but you can't open Word. I can't open WordPerfect, but I can open Word. There's got to be a better way to share information. That's where this common language of HTML comes from, okay? And HTML itself is actually a very simple markup language. There are overlays on top of it that make it much more complex and provide the rich web experiences we have today. But you were supposed to go out and look at the Wayback Machine. If you look at the Wayback Machine, you'll see websites are vastly different today. And that's because back in those days, we were only using HTML to build websites. Later on, we started having things called CGI scripts, written in languages like Perl. And then as the web progressed into the late 90s, we ended up having something that came along called Java. And Java is still around today, and some of you may have learned it in one of your classes. Okay, so we ended up changing the way that we did development. But over time, we developed other technologies like cascading style sheets or CSS, JavaScript, which, by the way, JavaScript and Java have nothing in common. They are completely different languages, no relationship to one another. It's a byproduct of confusing naming because of the popularity of the other. Okay, so JavaScript took on the name JavaScript because Java was starting to become popular, is the way I understand it. Okay. Let's see here. Graphical web browsers. So 1993, we had the first web browser that was graphical in nature. Before that point, a web browser wouldn't have been graphical. Okay, so you probably wouldn't recognize it if you saw it. But we end up with a web browser called Mosaic. Okay, and this is actually done at the University of Illinois. So academic institutions are where a lot of these inventions started, and then someone got the idea to monetize it and turn it into a commercial product. Okay. A year later, Netscape is formed, and Netscape takes the Mosaic browser that was developed by the founders of Netscape and release it as a commercial product. Okay. The first e-commerce is in 1994 on a couple of fronts. Number one, we have banner ads. Okay, so we start having commerce in the form of ads on websites. We also have companies founding payment systems. So 1994 is when First Virtual Holdings got its start, and First Virtual Holdings, along with Cybercash, were the first internet payment mechanisms that were available, even before credit cards could be used online. Okay. Now, that's not to say people didn't use their credit card online before that point. It just wasn't secure to do so. So why would you compromise your credit card by using it online? It just was unheard of for people to buy things online. Okay. Now, in 1985, the commercial internet is born. Okay. This is when the entire backbone of the internet is privatized. Okay. In 1995, we also had Amazon and eBay were formed, although eBay started off as auction web. And the reason why it ended up as eBay is because Pierre Omidyar, he's the founder of eBay, he had a domain name eBay for his consulting company called Echo. His company is called Echo Bay Technologies or something like that. He had the domain name ebay.com. So he was hosting the auction site, Auction Web, on eBay. Eventually, the company's name changed to eBay. Okay. For a long time, we had a government agency that was that had outsourced the domain name system to registration system to a third party called Network Solutions. Okay. And they ran the DNS for the internet, and it was a pain to get a domain name. Okay, very, very costly, very complicated. If you want to make any changes, it was not easy to do. I had a domain name back in, oh gosh, I don't know, I bought one in like 1996 or something. Okay. Extremely difficult to get a domain name and manage it. So around 1998 or so, they formed a nonprofit to manage the DNS for the internet as a whole and the domain name system. And that begat the ability for private entities to begin doing the registration. So that's why today you can go to GoDaddy or wherever you might want to go, Google or whatever, and register a domain name. Okay. Then we had in the early 2000s, we started seeing Internet 2, which is UCR has this on the campus. Okay. Internet 2 is a much faster link to the internet. Okay. And it's today, Internet 2 is still mostly used for academic purposes. It really hasn't been commercialized yet. Okay. Let's see here. Let's move on. We had net neutrality in the early 2000s came to being, which from my viewpoint kept things sane on the internet, avoided some of the troubles that other countries have had with respect to pricing of things on the internet. Mobile internet came about in the mid 2000s, starting in 2007. When the iPhone was released, the Android came a year or two later. Okay. By the time of the first economic crisis in 2008, 2009, we end up with smartphones starting to become fairly common. Okay. Then in the mid 2011s, we started seeing an expansion of the domain name system, which originally was .com, .net, .edu, .org. And now we start seeing .cloud, .me, all these other web domains popping up. We start seeing the Internet of Things, meaning a lot more devices connected to the internet. We start seeing hypermobile computing like watches and wearables. Okay. We start seeing transaction networks like Apple Pay and Samsung Pay. Then we see net neutrality repealed in 2018, and that's where we are today, is roughly around 2018, 2020. I don't know that much has changed in the last couple of years. Okay. So let's talk about some of the key technologies related to the internet. So first of all, we talked about TCP/IP as the protocol earlier. We use a method of packet switching to communicate on the internet, and on networks in general. So every bit of data that we send is broken down into what's called a packet, and those packets get broken up, sent on their merry way, and at the destination they get reassembled into a whole unit. Okay, and so we're going to pause for a second. All right. So anyways, I was saying packets come through. They get the data gets disassembled into packets, and then those packets get sent over your internet connection to the destination computer that they need to go to, say google.com. And then when they reach the destination, the TCP/IP protocol reassembles those packets into the data that you were sending or receiving. Okay. So you think of okay. All right, so in terms of breaking up the packets, we have to convert everything to binary. So binary is just ones and zeros, or on and off, if you think about it from like a light switch. A light switch is either on or it's off. So let's say I have a message of hello. That's my original message. I'm going to break that up into the ones and zeros that turn that into hello, so you can actually go look up on the internet, convert text to binary, and you get a message in ones and zeros. And then the ones and zeros are further broken up into packets, and then those packets are sent across the connectivity that you have. Okay. Now we use something called a router to basically interconnect and send traffic from one place to another. So we have a device called a router, and so if you see in the picture behind me, there is a router up there on the top. Okay, and the router allows connectivity between my home network and the internet. Okay, and most people have a router. If they don't have a router, then they're on a network that has a router beyond the point where you can see. So if you're living in the dorms right now, You may not have a router, but the campus does have a router in your residence hall for probably each floor, if not each pod within a floor. Next, the protocol. So we talked about the TCP/IP protocol. And so TCP/IP protocol is the core communications protocol of the internet. And a protocol is just a set of rules and standards for transferring data. But the best way I use as an analogy is think of it like a language. So if every computer agrees to speak English, then that's the that's the protocol that we're going to use. If every device decided that the proper language to communicate with one another is Spanish, then it would be Spanish. Right? That would be our protocol. We have protocols in our day-to-day lives. Businesses have these. So some businesses will say that we are going to transact business only in English or only in Chinese, or when we're in a U.S. office, we're going to transact with English language, but when we're in our Xi'an or Chengdu offices in China, then we're going to conduct it in Chinese. And if we're in Tokyo, that office, maybe we conduct our business using Japanese. Whatever it might be, it's the protocol that we've decided on to communicate. Okay. Now, you should, for the purposes of the exam at least, you should be familiar with the OSI model and the TCP/IP layers that are used, just like the OSI model for things like the network interface, internet, transport, application layer. Okay, so you should be aware of those. I talked about domain names already. Let's see here. Cloud computing. So we'll talk about cloud computing very briefly. So cloud computing in its simplest form is where we have various services such as storage, computers, network, applications, etc., that are contained in the internet, and we consume them as a service. Is the best way to think about that. Okay. Now there is a NIST definition, and it would be good for you to understand that definition. Okay. So on page 120, it goes into the definition, but at its core, it needs to be self-service, needs to be on demand. You need to be able to access it from anywhere. You need to have resource pooling. You need to have elasticity of the service. It needs to be measured, okay, in some way. And there are three basic service delivery types. So you've got infrastructure as a service, or IaaS, platform as a service, or PaaS, and software as a service, or SaaS. And so at the infrastructure as a service level, you as an organization are going to own more of the stack than if it's a platform as a service. And platform as a service, you own more responsibility than if it's SaaS. Okay. Now you can have a public cloud like Amazon Web Services, Google Cloud Platform, Microsoft Azure. You can have a private cloud, which is only used by one organization. Now it might be used by sub-organizations. So say GE buys a private cloud and sets it up. They may provide services to all of their different business units within the organization. A hybrid cloud being both public and private, and then multi-cloud being a little different in that it's public cloud, but it's multiple public clouds. Okay, so being able to do Google and Amazon and Azure interchangeably. Okay, I talked about hypertext markup language, HTML. What I didn't talk about yet was the protocol used by web browsers and web surfing. So Hypertext Transfer Protocol, or HTTP, is the internet protocol for doing web pages. SMTP, or Simple Mail Transfer Protocol, is the protocol for sending email, but not receiving email. Okay. For receiving email, I should say retrieving email. Retrieving email is better. The client that we use, whether it's a web browser client like Google Mail, or it's Outlook, or it's Thunderbird, or Apple Mail, or whatever it might be, that uses a protocol, one of several protocols, depending on how you set it up in your server. One could be the post office protocol. Okay. Another one could be the Internet Mail Access Protocol, or IMAP. The third could be you could have a service that accesses it using HTTP or HTTPS, okay, which is the Hypertext Transfer Protocol. Another service I mentioned earlier is File Transfer Protocol, or FTP, fairly uncommon these days. And then Telnet. Telnet, you would rarely see telnet these days because it's extremely unsecure. Okay? Now, secure sockets layer or transport layer security is what we use for security on the internet between us and the website. Okay? And for you, you can understand that by seeing the little padlock in your web browser. Okay? And then you have things like the ping and traceroute commands, which can be used to test your internet connection and troubleshoot. Okay, so ping and traceroute are things that you're going to be using probably pretty extensively. Okay, let's go ahead. The internet backbones using fiber optics. Okay, so these are glass cables that use light to transmit data. Bandwidth is how much data can be transferred over a fixed period of time. So generally these days, this is in megabits per second at the consumer level and gigabits per second at the high-end business level, but it can vary depending on your location. kbps is how things were measured during the dial-up days of using a modem. Okay? Redundancy, business class networks have redundancy, home networks generally do not. There are exceptions. The device behind me has actually got redundancy, so it's connected to two different internet providers. Only one is active at a time. If my primary provider goes down, the secondary picks up on the device automatically. There's actually a tertiary that I'm working on getting set up that uses cellular. So with everybody working from home, it's kind of a necessity to have a reliable network connection. But the other network up there, the other network equipment, is a single point of failure, so there's not a whole lot of redundancy in those boxes up there. Okay, within like the Wi-Fi realm, you can have redundancy there as well. So I have a Wi-Fi sitting up there, I have a Wi-Fi in the next room, and then two Wi-Fis upstairs. So if one goes down, the devices still can connect. That's called redundancy. All right. We mostly use broadband today. But there are places in this country still where narrowband is the only option available, especially very remote locations. Okay? And narrowband is when you use a telephone line to connect. Now, there are exchanges across the U.S. for the internet. Okay? And so if you think about L.A., this area, there is an L.A. exchange in L.A. There is a exchange in Seattle, in the Bay Area, in Seattle, I just mentioned. Chicago, Dallas, Minneapolis, Boston, New York, Virginia, Atlanta, and Miami. These are where the major internet access points for the U.S. are. Okay. Now, probably most people have digital subscriber line or DSL or cable internet. But some areas have fiber optics, also known as FiOS. Okay. And so that's actually what I have as my primary. Satellite internet is challenging because of latency. Okay, and upload speeds tend to be slower as well. Because if you think about it, those satellites are very far away. So it's going to take a long time for the signal to get back and forth. Okay, because we are limited by radio signals. Now, there are new technologies like SpaceX's Starlink, which are being developed, which fly at a lower orbit and therefore are able to have lower latency and faster speeds. Okay? Mobile internet today, we generally use 4G, but 5G is the next step beyond that. Okay? So 5G is extremely fast. 4G is faster than 3G and lower technologies, but still not super fast. Okay. Now, as far as wireless access points go, there's a variety of different technologies that are used. The Wi-Fi types, they have little letters on the end of 802.11, and they have different speeds and ranges. Bluetooth is a very short distance. That's known as a personal area network. Okay. And then Internet of Things. This is just us connecting any type of device to the internet. You know, cars could be an IoT device, refrigerators, appliances, sprinklers, lights, etc. Okay, so as an example, do this. Okay, so watch this light. This is the Internet of Things device. This light bulb's connected to the internet. Hey Siri, turn office light blue.
I've sent the request.
There we go. Hey Siri, turn off this light red.
Coming right up.
There we go. Okay. So that's the type of thing that we can do with IoT. The web. So I mentioned Mosaic before. I mentioned Netscape, Internet Explorer, Edge, Chrome, Safari. These are all modern browsers. Okay. Netscape doesn't exist anymore. The closest thing is Firefox, and Internet Explorer has been replaced with Edge. Okay. Hypertext, I already mentioned that. Let's see. I mentioned CSS. XML is an additional language that does additional formatting, but we tend to see XML used more for data transfers, although it's being replaced by JSON, JavaScript Open Notation Language. So although you do still see XML in some cases, JSON or the JavaScript Open Notation is much easier to use, so it is being preferenced. When you have a web system, you have things like a web server, which serves the actual web pages to you. You tend to have an application server behind the web server that sends non-static content to you. So static content would be things like pictures, plain text, videos. Okay. Application servers, on the other hand, are going to serve up dynamic applications. So that could be dynamically generated content. It could be e-commerce server. It could be a lot of different things. Okay. When you connect to iLearn, there is a web server, there is an app server, and there is a database server. There might be other things as well, but those are the things that I know of for an application like that. So the app server is going to be making sure that anything dynamically created for you is there. So when you open up, say, the assignments page, that's a dynamically generated page. That content is coming from the app server, but it's being fed through the web server. Okay. When we have email, we have mail servers. If we're doing video clips like, say, YouTube or something, YouTube is a video service, so they run their own video content servers to stream. But if you host it yourself, you'd have to have a video content streamer. And then moving on, so email's been around for a very long time, and it's still being used. Okay? It's the most used application on the internet. We have instant messaging, so things like Slack and Google and Microsoft Teams and things like that. Message boards, not as common these days. We have internet telephony, voice over IP. You may have heard of that. Some telephones now are on VoIP, although you'd be hard-pressed to find VoIP around the UCR campus. Most of the telephones are still using non-packet switched networks, which means for every phone device, you have to have a physical wire to connect it back to the switch, which means when people change offices, it's very costly to move their telephone around. Okay? With VoIP, we don't have to worry about that. I used to have a telephone for work that I would take on business trips with me. Okay? And it allowed me to plug it in anywhere I had a network connection, and there we go. I could get on the make phone calls just like I was sitting at home, okay? Or in my office. Search engines are used to find information. So Google is the most popular today, but we also have things like Bing that exist. And before Bing and Google, we had Yahoo and InfoSeek and WebCrawler and Excite and Ask Jeeves. Okay, a number of others. Okay. We have things like blogs, so we can have a web page, which could be either for an individual or a company, where we share information. So as part of your assignment, you're building a web page and a blog. Okay. Wiki is just a web application where we can share documentation and all update it. So like Wikipedia is a good example. VR and AR, virtual reality, augmented reality. Gosh, I hope that the campus reopens soon and you can get a chance to test those out at the Science Library. Okay, the Orbach Science Library has virtual reality that you can use, assuming that we reopen at some point. So hopefully this goes behind us soon. But augmented reality, probably many of you have already played Pokemon Go. That's augmented reality. Although there are a lot of business use cases for this, the IKEA Place app is a great example. So look at the IKEA Place app or the Google Translate app. Those are great examples of augmented reality. IKEA Place lets you try out furniture in your home without going through the hassle of installing it and putting it together. Okay? And then you can buy it right there if you like it. And then the translate piece, you can hold your phone up to any type of text and it will convert it to the right language of what you want to see. Okay. All right. Careers. So there's a lot of different things you can do in terms of careers, and so I won't get into that. Read through the book. You can see some examples there. The same examples I talked about last time are going to be applicable for this chapter. Okay. But there's going to be a lot of technology roles associated with e-commerce. Now, I will be back in just a moment here with Chapter 4. Okay, so now we're going to go on to Chapter 4, which is building an e-commerce presence, which some of you have already done. All right, so let's go ahead and think about the process. So hopefully those of you who did the homework already, hopefully you've thought about what you want to build before you actually build it, because the best way to build something most efficiently is to think about it and go through the process of coming up with ideas. Okay, so what is your idea? That's the vision. Figure out what your revenue and business model is. Okay. Who's your target audience? A lot of systems launch without understanding who their target audience is. So if you cannot concisely and clearly articulate who your target audience is, you don't know who it is. Okay. You should understand the marketplace. And actually, I teach the entrepreneurship course when it's offered. And what I noticed in that class, as well as in the, there's another class that we did something similar in, but I don't remember which one now. But what I did notice was a lot of times there was not a good understanding of the market and not a good understanding of who the competitors were. So not only you have to be crystal clear on who the market is that you're targeting, and what that marketplace looks like, your size, who the competitors are, but you also need to understand what realistically can you actually achieve in that market. So it's one thing to say you have a $100 billion market opportunity, but don't go trying to say you can capture 10% or even 1% of that market, because it's unrealistic. If you think about 10% of 100 billion is 10 billion and 1% being 1 billion, how realistic is it a company with no infrastructure, very small team, etc., being able to go after a $1 billion market? The reality is you're talking a fraction of a percentage of that market. Now, over time, you might be able to get that number up, but if anybody goes in, and some of you may want to be entrepreneurs, if you go into a VC and you say, yeah, it's a $100 billion market and we're going to capture $1 billion of it, you're going to get laughed out the door. Okay? So make sure you have realistic numbers. Now, one thing you can do is a SWOT analysis. Actually, let's take a step back. One more thing is content. So you need content for your site, and you got to figure out where that content's going to come from. Is it something that you're going to produce? Is it going to be dynamically created, or are you going to have to license that from someone else? Because you can't just go pull content from someone else's site and use it on your own, because that's a copyright violation. Okay? So you got to think about what can you actually realistically do. Now, I said SWOT analysis, but I want to cover one more thing first. We have a business model canvas that I've posted. Right? You're going to have to do those for organizations. Okay, so if I have one for you to do as part of one of your assignments, but that's the sort of thing that you would do for a real business as well. Now, the SWOT analysis, there's a lot of templates online for this. I think, if I recall correctly, Lucidchart has one as well. Lucidchart's free for students. You have a SWOT analysis, so your strengths, your weaknesses, opportunities, and your threats. And then you want to look at perhaps doing an e-commerce presence map. So what types of presences are you going to have? Is it going to be a website, an app, social media? You're going to do offline media? And then what types of activities for each one of those. Okay? You may do a timeline associated with your e-commerce presence. So you might have phase 1 might be planning, phase 2 might be development, phase 3 might be implementation, etc., etc. Each one of these phases, you're going to have activities, and you're going to have a milestone that comes from that activity, whether it's a plan or a website or something else. Okay? Now, if you're developing a website, you need to have some sort of budget for that. Now, if you're just starting out, and let's just say you're doing something personal. I have a personal website. There are no costs from a personal website other than the hosting costs. So the example given in the book is for an average organization to come up with developing their website. So you're going to have things like your hosting service, your software, any hardware. But if you do cloud, you can kind of mash those things all together. Your marketing, the content development, the design. Okay, so you can do a lot of this stuff yourself, but you're still going to have some sort of cost unless you use a free website host. Okay. All right. So then the other thing you're going to have to think about is the software or systems development lifecycle (SDLC), okay. And this is broken down into some major components: system planning and analysis, design, the implementation. The building of the system, the testing, and then the implementation and maintenance. Okay. So you want to go through the book and read through that for the exam. Okay. Now, in-house versus outsourcing. So when you're first starting out, you might outsource a lot of things. But as you build your organization, you are probably going to find that if it's a core competency of your business, it's probably cheaper in the long run to do in-house. But you're going to have to make that analysis yourself based on your specific situation. Now, some things are usually outsourced these days, like hosting. So a lot of times organizations will host their website. Right? They won't necessarily, not every organization hosts their e-commerce aspect, but they'll host their corporate website at least. Right? And you can kind of mix and match as to what makes sense. Now, you usually will need some sort of content management system for your website. And so WordPress is one such example of that. I use, oh my gosh, what do I use for mine? Webflow. I use Webflow. Okay. There are a number of different CMSs out there. Some cost money, some are free. WordPress has a free version, they have a paid version. Okay. The advantage of picking one that is pretty prevalent out there is you will get a lot of features added to it. You'll have a lot of plugins available, and there will be a lot of community support. But you'll have to determine what you want to use. Are you going to use templates? Are you going to do things from scratch? Are you going to use tools that exist out there? Okay. Let's see here. There's some easy providers you can use, like Wix and Weebly and other things like that. You need to make sure you test. You're going to want to test for different features. If you've got multiple versions, test for that. You're also going to want to test for accessibility. Depending on the business that you're in, you might be restricted and required to comply with ADA or WCAG, Web Content Accessibility Guidelines. You might have to comply with one or both of those rules when you build your website, so you want to consider that. There are a lot of free tools for doing testing, but there are also third parties who can do a full-blown testing for you. Okay. Then we've got things like benchmarking, so you compare a site with your competitor. Okay. Optimize your web performance, so you're going to want to do testing and do optimization of your application, your code, your images, etc., to make sure that it works on all browsers and all types of connections. Now, some of the things you might do is you might do prototyping, where you build something, prototype it, see what customers think or potential customers think before you go and build the whole thing. This is the approach I always tell my students is a wise approach, prototype. Okay? It's lower risk. Agile development, so you break a project up into smaller projects that you can complete in a shorter period of time, usually called a sprint. And that happens in usually about a 2-week period that you break things into a sprint. But it could be 1 week, it could be longer depending on your organization. DevOps, so we build development type practices into our operations, and we have a culture of rapidly iterating and responding to our customers' needs. Microservices or web services, we basically build loosely coupled reusable software components as opposed to a big application. So if we need the application to print an ID badge, then we build an ID badge service, and that's all it does. If we need a service to collect payments, we build a service that just collects payments. It does nothing else. We need a shopping cart. We build a shopping cart service, and that's all it does. Okay, you get the picture. Architecture. So we can do simple versus multi-tiered, and so this gets into what I was talking about earlier when I was talking about DNS. Of you can have these very complex, very highly resilient, and very expensive architecture, but you also save yourself the outages and potential lost revenue. Or you can have a very simple one web server, run everything, but if it goes down, you're totally screwed. Okay, so you can go at opposite extremes. Many organizations go somewhere in the middle. Okay, let's see here. I think we can move on. Web server software. So there's a lot of different options out there. Primarily Nginx, Apache are the two big ones today, but there are other web servers out there. Application servers, there are a variety. It depends on what you're actually building. So you want to do some research on application servers. You're looking for Java or something else. Merchant servers usually handle things like credit card processing and shopping carts. Shopify is a cloud-based one that you can use with, say, WordPress, for example. Open source software. Open source means the source code's available for modification. It doesn't necessarily mean free software, but usually you can find free versions of open source software out there. Okay. But with open source, you get the community maintaining that software and building functionality and finding security issues. With closed source, you do not. And so closed source would be like Microsoft Office. The only people with the source code are those who work at Microsoft. Okay? Whereas open source, I can go out to GitHub and see the open source for any of those products out there. Hardware, if we're doing cloud, then we don't need to worry about this so much, but if we are building out our own infrastructure, our own data center, then we have to actually figure out the details of hardware. We can vertically scale, so we put it on larger and larger hardware. If we horizontally scale, we put things across multiple smaller, cheaper pieces of hardware. Okay. Web-based architectures these days typically fall into the horizontal scaling with lots of cheap commodity hardware. Legacy applications tend to be found on vertical scaling, where I might have to go buy a $10 million machine to run my application, but it will run it because it's very large. Okay. The alternative is I could go buy 10,000 cheap machines and run my application if it was horizontally scaled. But with that horizontal scaling comes the complexity of management, which is why over the last 15 years or so, we've seen a huge amount of tool development. Okay. SEO, search engine optimization, so their entire course is based on this, but effectively you can get into this field and optimize searches for content that's being found on the internet. Interactive web content started off with CGI, or Common Gateway Interface. I mentioned that earlier, but we've shifted to other technologies. ASP is Microsoft's solution, ASP.NET. On the other side of the coin, you have Java server pages, and JavaScript. And then going back to Microsoft, you also have ActiveX and VBScript, although you don't see these a whole lot. Okay? Especially since newer Microsoft browsers don't support these. Cold Fusion is another version of interactive development environment. Ruby on Rails, PHP, and then Django. Okay, these are all different applications that can be used for dynamic content generation. We can do personalization. We can have privacy policies in our applications, which is quickly becoming a necessity with laws that we'll talk about later in the course. Okay. Mobile website versus native apps. So we can have mobile websites, mobile web apps, which are basically just an application which opens a mobile web browser and wraps it. We can also have a native app. Okay. And so we can have different versions of things. So Facebook fits into that mobile web app, and a native app would be, say, Pokemon Go for the iPhone or Pokemon Go for the Android. How you build your mobile presence, it's not just building it, but it's maintaining the currency of your content. So you're going to have to think about that. You're going to have to think about, are you going to do responsive web design, which means no matter what, your design will automatically adjust to whatever screen it's on, if it's a mobile app or mobile device or big device or whatever. Okay. Or are you going to do adaptive? Let's see here. And that's it. Well, okay, the last thing I'll mention is in the career section of the chapter, there's a comment about UX designers. UX designers are a cool career. I think so. I'm not one. I'm not great at UX. But this could be a very lucrative field for those of you who have creative backgrounds and also the ability to really understand what people look for. So really understanding what users want, whereas engineers typically think about what they would want, but what they want and what a user would want are two different things. And I use the example of Apple versus Google, a prime example of this. Apple's very user-driven, okay? They look at the user experience. They try to provide a beautiful user experience that's seamless. Google is very engineering-driven, so things are driven by what engineers think the user wants. Two different mentalities, and if you look at Google services, sometimes it's an exercise in frustration in using them, and that's because it made sense to the engineer, but the user experience wasn't thought of until after the fact. Okay? All right, that is it for this week's lecture.